last time we have studied the first fit algorithm. This lecture we will study the base fit algorithm. So what base fit says, allocate minimum sufficient block. What is meaning of a sufficient block? As we have studied in the last lecture, the sufficient block means process size should be less than or equals to block size. Process size should be less than or equals to a block size, that is called as the sufficient block. So we have to allocate a process into a minimum sufficient block. Okay, now we will try to allocate the processes starting from a first process 12k. Now 12k, there are sufficient blocks are 15k, then 25k is sufficient, 30k is sufficient, and 40k is also a sufficient block. So these are the all sufficient blocks because size 12 is less than 15, less than 25, less than 30, less than 40. But out of this we have to select a minimum sufficient block. So which is the minimum sufficient block? Block number 1 of size 15. 15, 25, 30, 40 are the sufficient blocks. But out of this 4, minimum is a 15. So we have to allocate a process P1 into a block of size 15. So P1 will get allocated here of size 12k. So this is allocated process here, and the internal fragmentation that will remain is a internal fragmentation. What is fragmentation? Internal fragmentation I is equals to block size minus process size. So block size here is 15, process size is 12, so internal fragmentation is 3k here. Okay, so this is the allocation of the first process. Now second process is 2k. Now for 2k, all the blocks are sufficient. That means 10k, 5k, 25, 30 and 40 all are the sufficient blocks, but the minimum sufficient is a 5k. So allocate a process P2 into a block of size 5. So this 2k process P2 will get allocated here, and the internal fragmentation remain will be a block size minus process size, block size 5, process size 2. So internal fragmentation is 3k. Internal fragmentation here is again a 3k. Now next process we have to allocate is process number 3 of size 25k. Now for 25k, what are the available blocks? Available blocks are 10k, 25k, 30k and 40k. Out of that, sufficients are 25, 30 and 40. For 25k, sufficient block is 25, 30 and 40, and out of that minimum is a 25. So we will allocate a process P3 of size 25k in a block number 3 of size 25k, block number 4 of size 25k. And here internal fragmentation, what will be internal fragmentation? Block size minus process size. Block size is 25, process size is 25, so internal fragmentation is 0 here. Now next process we have to allocate is 20, and for 20 available blocks are this 10, this 30 and this 40, and out of those minimum is a 30. So we will allocate a process P4 in a block of size 30. P4 equals to 20k will get allocated here in block of size 30, and internal fragmentation it will leave is 30 minus 20 equals to 10. Internal fragmentation I is equals to 30 minus 20 is 10k. Okay, now all the processes are allocated in the blocks. Now we will calculate the internal and the external fragmentation. So fragmentation, first internal. So what is internal fragmentation? This is I 3k here, this is I 3k here, and this is 10k here. Internal fragmentation is internal to the block. So this is 10 plus 6, 16k. And what is external fragmentation? External, the unutilized blocks. Which one are unutilized? The 10k block is unutilized, plus this 40k block is unutilized. So this 10k plus 40k is equals to 50k is the external fragmentation. So this is how base fit algorithm works. In base fit you have to remember that allocate a minimum sufficient block. Sufficient means process size should be less than equals to a block size, and minimum means whatever are the sufficient blocks, select the one which has the minimum size, minimum sufficient block. Thank you.